Okay, so sorry that I'm not there today. Kellen is homesick, so I had to stay home with him. So I'm gonna just do this video quickly for you guys for 2.4, and then I'll be back tomorrow for our review day so that I can answer any questions for you prior to our quiz on Wednesday. So today we're gonna talk about complex numbers, which is imaginary numbers. We're just gonna go through a whole bunch of examples, and then you guys should be able to figure out your homework and kind of the types of questions that you'll be asked. So warm up, go ahead and press pause and give these a try, and then press play when you're ready to check your answers. All right, so whenever we're multiplying with radicals, we're going to multiply just the same way. So we'd have root 2 times root 3 gives me root 6. Root 2 times negative 2 is negative 2 root 2. 3 times root 3 is plus 3 root 3. And 3 times negative 2 is minus 6. We can only ever simplify with radicals if either A, something comes out of them, but also B, if they have the exact same radical in them. So I cannot add or subtract these. So that is our answer. For number 2, we have a radical in the denominator. So we need to multiply by the conjugate and multiply by 2 plus the square root of 3. 2 plus the square root of 3. This is a flashback to what we did in chapter A. So in the numerator, I'd have 1 times a 2 plus the square root of 3. So we just leave it like that. In the denominator, I have 2 times 2 is 4. 2 times root 3 is plus 2 root 3. Negative 3 times root 2 is minus 2 root 3. And then minus root 3 times root 3 is just 3. So notice those 2 root 3's would go away. And I'm left with 2 plus root 3 divided by 1, or just 2 plus the square root of 3. Okay, so jumping into dealing with imaginary numbers, if I were asked to solve something like this, x squared plus 1 is equal to 0, we do x squared is equal to negative 1. In the past, you've always been told that when you take the square root of both sides, that you cannot take the square root of negative 1. The purpose for being told that is that it wasn't within the realm of the real numbers anymore. So, but it is within the realm of the complex numbers, and that's what we're learning about today. So I want to direct you guys over here to this definition. The definition is that the letter I, it kind of looks like a variable, but it's not representing a variable number. The letter I is equal to the square root of negative 1. So if I have x squared is equal to the square root of negative 1, or sorry, the square root of x squared, I'd have x is equal to plus or minus I. Notice that I'm just replacing that square root of negative 1 with I. Sorry if you hear a little soundtrack in the background of my dog drinking water and walking around. And my husband laughing. So notice down here, complex numbers. We have a plus bi. That's how we always want to write this. The a is the real part. The bi is the imaginary part. We're going to talk about this. It's really important that we separate the real part from the imaginary part. We can always combine real numbers together. We can always combine imaginary numbers together, but we can't really combine the two of them. I is very interesting because of how it's kind of set up. So since I is equal to the square root of negative 1, I squared, I'm going to write this over here, is the same thing as the square root of negative 1 times the square root of negative 1. Or we could think of this as the square root of negative 1 squared. Now, we can think about the square root and the squared canceling each other out. So I squared is the same thing as negative 1. Anytime that you ever see I squared, I do not want you to write I squared. I want you to simplify it to negative 1. I cubed, okay, let's think about that one. This would be the same thing as I squared times I. Well, that'd be negative 1 times I. So that would just be negative I. If you have I to the fourth, this would be the same thing as I squared times I squared, which would be negative 1 times negative 1, or positive 1. Okay, notice that I don't have to write I with any exponents. I can always simplify it to either just I, negative 1, or positive 1. Let's go over to I to the fifth. I to the fifth is equal to I to the fourth times I. Well, I to the fourth is really important because it's equal to 1, so that's easy for us to simplify. I'd have left just an I. I to the sixth is I to the fourth times I squared, which would just be negative 1, because it'd be 1 times I squared, which is equal to negative 1. I to the seventh is I to the fourth times I cubed, so 1 times negative I. And I to the eighth is I to the fourth times I to the fourth, which would be 1 times 1, or just 1. So notice this pattern. I, negative 1, negative I, 1. I, negative 1, negative I, 1. You can probably guess I to the ninth is going to just be I. This would be I to the fourth times I to the fourth times I. Okay, 1 times 1 times I. We can do this with even higher powers. So for I to the 27th, think of I to the 27th as, okay, what's a number that goes into, or that 4 goes into? This would be like I to the 24th times I cubed. We all agree there. The reason that I chose 24 is because I to the 24th is the same thing as I to the 4th power to the 6th power. Power to power we multiply, times I cubed. Well, this would be 1 to the 6th power times I cubed. Really, that 1 to the 6th power is just 1, so this is the same thing as I cubed, or negative I. How about I to the 52nd power? I to the 52nd power, well, let's think about it. 52 divided by 4, we'd have this as, it goes in 1 times, so that would be 4. Yay, long division. And then we bring down the 2, goes in 3 times. Hey, look, what do you know? This goes in evenly. So really, this would be like I to the 4th to the 13th power. And you might have recognized that already. So this would be equal to 1 to the 13th power, or just 1. All right, we're going to practice simplifying with some radicals here. Always pull out the negative first and deal with the I first. So the square root of negative 36 would be like the square root of negative 1 times the square root of 36. So this would be the square root of negative 1 is I. The square root of 36 is 6. Hold on, I'm going to see. Excuse me. So 6 or I times 6, we typically will write i's like we do other variables. So write it as 6i. I always have it after the coefficient. Moving on, with the square root of negative 48, break that down again. So the square root of negative 1 times the square root of 48. And if you don't know what the square root of 48 is, that's okay. Just make yourself a quick little factor tree. 2 times 24, 2 times 12, 2 times 6, 2 times 3. I'm looking for square roots, so I'm looking for pairs. So from the square root of negative 1, I have an I, and then I have 2 groups of 2 that I can pull out, so that'd be 4, and then the square root of 3 is left over. So I'd write this as 4 times I times the square root of 3. For this last one, I would have the square root of negative 1 times the square root of 21. Well, 21 is just 3 times 7. So I end up with I times the square root of 21. Done. Okay, so always pull out that I first. Okay, moving on. Writing as a complex number in standard form. So remember, standard form is that A plus BI. We're going to talk more about that on a couple of slides, but you should always have your real part first and then your imaginary part second. So for D, what we're going to need to do is we need to simplify each piece before we can add these together. So 5 is just 5 plus the square root of negative 36. Last slide, we saw that that was 6i minus 12 plus 2 times I to the 5th. Well, I to the 5th, remember, was I to the 4th times I. So this is 1 times I, or I to the 5th is the same thing as I. So this would be plus 2i. So when I add my real parts together, I have 5 plus or minus 12 is negative 7. When I add my imaginary parts together, I get plus 8i. 6i plus 2i is 8i's. Notice a real part and an imaginary part. Okay, for my second one, I have 4 minus the square root of 3 would be the square root of negative 1 times the square root of 3. So this would be I times the square root of 3. Again, notice, real part, imaginary part. I'm actually done on that one. All right, getting a little bit more challenging. F is actually already simplified. However, it's not in standard form because there's not a distinct real part and a distinct imaginary part. So we have to break that up. We'd have 3 divided by 16 plus 4 over 16i. And then notice that I can simplify that 4 over 16. So this would be 3 over 16 plus 1/4 I. That would be fully simplified and in standard form. Okay, G. For G over here, I have 5 plus I divided by 2 minus 3i. So when I do this one, you need to be careful because I is representing the square root of negative 1, which means I is representing a radical, which means that you have a radical in the denominator. So what do you need to do? You need to rationalize. We're going to rationalize this just like we did in our warm-up. We're going to multiply by the conjugate, 2 plus 3i over 2 plus 3i. Now, remembering that you need to FOIL these, okay? And we'll do this the exact same way that we were rationalizing previously. So go ahead and just FOIL these out. So I'd have 5 times 2 is 10. 5 times 3i is plus 15i. I times 2 is plus 2i. I times 3i is plus 3i squared. In my denominator, I'd have 2 times 2 is 4. 2 times 3i is plus 6i. 2 times negative 3i is minus 6i. And then negative 3i times positive 3i is minus 9i squared. Now we want to simplify these. The first thing that I'm going to do is go in and change those I squareds. Remember, I squared was equal to negative 1. So I would rewrite this plus 3 as minus 3. I'm going to rewrite this minus 9 as plus 9. And then a couple of other things. I noticed that these 6 i's can cancel out. Okay. So I'd have 10 minus 3 is 7. Plus 15i plus 2i is 17i. Divided by 4 plus 9 is 13. Now, that's in simplified form. I can't simplify any of those numbers any further, but it's not in standard form. So I need to rewrite this in standard form. 7 divided by 13 plus 17 over 13i. That would be my final answer. Okay, so this one seems a little bit more simple, but I just want to make sure that we're clear on this. We always want to make sure to pull out the I first or change this in terms of I first. So for example, the square root of negative 3 would be I times the square root of 3 times I times the square root of 3. And I can multiply the i's together to get I squared, multiply the root 3's together to get 3. So this becomes negative 3. I squared is negative 1 times 3 is negative 3. The reason that I even bring this up is because for some people this can be a little bit confusing. If I were to think of it this way, the square root of negative 3 times the square root of negative 3 is the same thing as the square root of negative 3 times negative 3. Well, that'd be the square root of 9, and the square root of 9 we know to be 3. Notice that if I do it this way and I don't pull out and evaluate the i's first, I lose that negative. So this is not what we want to do. We want to make sure that we are evaluating the I first. Okay, so you should be able to do this. You should be able to add, subtract, multiply, and divide with i's. So I have a value for m, I have a value for n. I want you to press pause and try adding, subtracting, multiplying, and dividing them. Press play again when you're ready for the answers. I'll go through those answers pretty quickly. Okay, m plus n. We have 4 minus I plus 3 plus 2i. So adding the real parts, I have 7. Adding the imaginary parts, I have plus I. Number 2, n minus m. Make sure you didn't do this backwards. n is 3 plus 2i minus 4 minus I. Also make sure that you distribute that negative into both pieces. So I'd have 3 minus 4 is negative 1. 2i plus I minus a negative I would be plus 3i. N times n, n times m, I'd have 3 plus 2i times 4 minus I. So I'd have 3 times 4 is 12. 3 times negative I is negative minus 3i. 2i plus times 4 is plus 8i. 2i times negative I would be minus 2i squared. Again, I'm going to change that I squared to be negative 1, so this would become plus 2. So I have 12 plus 2 is 14. Negative 3i plus 8i is plus 5i. And then the last one, I'm going to go ahead and move up here just so I have a little more space. M, which is 4 minus I, divided by n, which is 3 plus 2i. Notice that we have a radical in the denominator because there's an I in the denominator. So you're going to need to rationalize by multiplying by the conjugate. 3 minus 2i, or 3 minus 2i. So in my numerator, I have 3 times 4 is 12. 4 times negative 2i is minus 8i. Negative I times 3 is minus 3i. Negative I times negative 2i is plus 2i squared. In my denominator, 3 times 3 is 9. 3 times negative 2i is minus 6i, plus 6i. And then I have negative 2i times 2i would be negative 4i squared. Change those I squareds to be negative 2 and plus 4. The 6i's go away. So I'd have 12 minus 2 is 10. Minus 8i minus 3i would be minus 11i. Divided by 9 plus 4 is 13. So in standard form, this would be 10 divided by 13 minus 11 over 13 times I. Again, I did those pretty quick, but you should have done them on your own first. Okay, last couple of examples. How can we use these I's in the context of what we've been doing previously? So if we look at this and we're being asked to solve, for this first one, I have x squared minus 2x plus 10. My first instinct is, hey, let's look and see if we can factor. Well, we can't factor, so that's not going to help us. So you can either complete the square, or you can also use the quadratic formula. I'm going to go ahead and use the quadratic formula. So I'd say x equals negative b, positive 2, plus or minus the square root of b squared. That would be negative 2 squared is 4, minus 4ac all over 2a. All right, let's simplify. So this would be 2 plus or minus the square root of 4 minus 40 over 2. So this would be 2 plus or minus the square root of negative 36 over 2. Come up here. Oh, the square root of negative 36, we know that. We did that earlier in this lesson. 2 plus or minus, that would be the square root of 36 is 6, and then I also have that I divided by 2. And just like when we were simplifying before, we can, if every 2 goes into everything, we can cancel a 2 out from everything. So this would be 1 plus or minus 3i. Okay, that would be my final solution there. Now, what does this look like graphically? Well, this would be a quadratic, right? And typically when we're solving for x, the solutions would be the x-intercepts. So what this means is that if this is a, if the x-intercepts or if the solutions that we get are complex or imaginary, that means that there's no x-intercept, which means graphically, and this is just like a rough sketch, my graph is probably going to be something along those lines, right? Notice that the vertex doesn't ever cross over onto the other side. So it might be shifted somewhere else or something like that. But notice that there's no x-intercepts for that graph. Okay, go ahead and try part M. Pause it and then come back and double check your work. Okay, once again, we could try and factor, but factoring may not be helpful, and you might look at this and be like, I don't even want to try to factor with that one. So let's jump straight into the quadratic formula and see what happens. X equals negative b, positive 2, plus or minus the square root of b squared minus 4ac all over 2a. Sorry for my late night singing. So I'd have x equals 2 plus or minus the square root of 4 minus 30 times 4 would be 120 divided by 10. So this would be x equals 2 plus or minus the square root of negative 116 all divided by 10. Square root of negative 116, I know there's going to be an I in there, but I don't know what 116 is, so let's go ahead and break it down. Something that I know for sure goes into 116 would be 2 maybe. Okay, so 2 goes into 116, and then I would have 58. Okay, and 58, 2 goes into 58, right? And then I would have 29. Okay, and then I don't think that anything else goes into that, so I could pull out a 2. So this would be coming up here, x equals 2 plus or minus 2 times the square root of 29 over 10. And notice, oh, I almost forgot my I because of the negative here. So notice that a 2 goes into each of those, so I could simplify this as x equals 1 plus or minus I times the square root of 29 divided by 5. And if I asked you to write this in standard form, we could write this still with a plus or minus. We'd have 1/5 plus or minus root 29 over 5 times I. Okay, and again, with this one, we would have no x-intercept graphically, so that's what we'd be looking at there. Okay, so go ahead and use the remaining class time to start working on your 2.4 homework assignment. And if you have any questions, feel free to just hang on to them, make yourself a note or something like that, so that you can tell me or ask me on Tuesday. I will definitely be there on Tuesday. So have a great day. I'll see you tomorrow. Bye.